Last class we had learned some sub procedure with string argument, and today we are going to do some sub program with numeric argument, and for that we are choosing the program related to the factors. So when you have here, write a program to read a number and print its factor using sub. What we need to do is we need to read a number. Let's say we read a number 8 and we need to print its factor. So input number is if 8, then our factors will be, as we know mathematically, 1 is its factor, 2 is its factor, and the next 4 is its factor. Yes, and then 8 also is its factor. So how actually we do this is we know it mathematically, but to make the computer do this work, how we need to instruct computer is we need to generate a number, let's say generate series of numbers 1 2 3 4 in that way up to 8. Yes, and now from these numbers, whichever number can divide the given number 8, those number are its factor. Like we check by 1 can divide, so its factor. 2 also can divide 8, 2 is also its factor, we print that. 3 is not its factor, so will not be printed out, we don't need to print this. In case of 4 can divide 8, so 4 is also to be printed out. After that 5 cannot divide 8, 6 also cannot, 7 also cannot, and finally 8 can divide. So it can print factors in this way. That means when the number is in a variable, the series of numbers are also to be generated in one variable, and that variable, this variable I here, I am writing here, need to divide the given number n, and if during that it is found divisible, then we will print the number which is dividing it. So in program, let's see how do we do that. Let's see if our input number is n. Yes, then what we need to do, we need to generate number from 1 to n. So for I equals to 1 to n, and this I need to divide the n, and we need to check the remainder. That is, if n mod I equals to 0, then this means the number n is divisible by I. This means I is its factor, so we can say this I is its factor and we can print it, print I. So for the first instance, value of I will be 1, and definitely 1 can divide any number. We'll print this. In case of next value of I, if we do next I, we are not writing here steps, so value of I this next time will be 2. 2 can divide or not, that will be checked. So during that time, let's see first its logic by making a trident table. Here for this we have here n and I, and then the condition checking is not needed to be mentioned there, and print statement is here, so print. Okay, let's take the example of n as 8. So during input, if value of n is given 8, n is 8, what happens here? I equals to 1. For the first time, value of I will be 1. From here it comes over here, 8, n means 8, 8 mod 1, I means 1 this time. 8 mod 1 means when 8 is divided by 1, remainder comes here 0. When the remainder is 0, this left hand side also 0 and right hand side also 0. That means condition matches here. That is, condition is true. If the condition is true, statement return after this then will get executed. That means print I will be executed. So this time print I will print value of this I. Value of this I is 1, so it prints 1. So from here it comes to next statement. So next I will make the value of I to 2, as step is not mentioned here. So when the value of I becomes 2, n mod I means 8 mod 2. 8 mod 2 means 8 is when divided by 2, it can divide 4 times, but remainder is 0. So as remainder is 0, this time also 0 equals to 0 condition true. Then print I. Sorry, I forgot to write the increased value of I here, made by this next statement. So 8 mod 2 also makes 0, and 0 equals 0 true, and print I this time will print the value of I. Value of I this time is, this one is replaced by 2, so this time value of I is 2, and this 2 will get printed out. After this, next I, the next I will make the value of I this time to 3, replacing the previous value 2. Now when it comes from here, 8 mod I mean 3 does not make 0, it gives the remainder 2, so does not make 0, the condition is false here, this statement will not get executed. So next I will make the value of I to 4. When the value of I is 4, it comes over here, and 8 mod 4, 8 is when divided by 4, it can divide 2 times, and the remainder will be 0. So 0 equals to 0 is true. When it is true, this statement will get executed. That means print I will be executed this time. Value of I is 4, and that will be printed out. Now next I makes the value of I as 5. When it comes over here, 8 mod 5 does not make 0, so the statement will not get executed. Then next I makes it 6, and when it comes from here, 8 mod 6 also does not make 0, so the statement will not get executed. And next I makes it 7, value of I as 7, and 8 mod 7 also does not make the remainder 0, and the statement, the condition will be false, and this statement will not get executed. Then next I makes it 8. On making the value of I as 8, when it comes over here and checks here, if 8 mod 8, 8 can divide 8 for once, and remainder comes 0. As from this portion left hand side, it gives 0, 0 equals to 0 on the right hand side, statement, sorry, condition is true. When this condition is true, print I will happen here. So print I has value 8, and 8 will be printed out. So on running this much, what will it give? It will print 1 is 2, 4, and 8. It will print these 4 values. They are actually the factors of the input number 8. So for completing this program, how do we write is as we need to declare a sub, declar, declare sub, as it is going to print factors. Let's write factors, factors, and input a number, and let's remove this all, and CLS, we need to take input, enter a number, let's write num, and it is to be passed to the procedure during calling factors, factors num. The input variable num is passed over here, and we've finished the main program. And now it's time to write the definition. The definition starts from sub, whatever we write here in declare statement, we write the same, sub factors n, sub factors n. And now all the things that we need to do is the same, nothing more to be done over here in sub. So now let's check, does it work or not? And if we give the input 8, it should print 1 2 4 8. Does it work or not? Let's see. Let's run it, creating exe. So enter a number and given here 8. So it gave 1 2 4 8. That means the program that we had done is correct. So this is the way how we write the program to find factors. Now, along with this, we can do another program, WAP, to read a number and print let's write and count its factors using sub procedure. If it gives if the question is like this, what change we need to make here is we just have printed the factors, whichever value of I can divide the given number, as that is its factor, we had printed that value of I. But as we are said to count the factors here, instead of printing, we use a counter variable here. So as it is going to count factor, let's use variable f for counting it. Now if we do like this, if the condition is true, that means if the factor is found, then instead of printing that factor, the value, the counter variable f will increase its value by 1, means it start counting this. So whenever the loop gets complete, all the factors will be counted out in this variable f. So if we print here number of factors f, if we do this, then it will give us the number of factors here. Let's check it. If we give it, at the time it printed 1 2 4 and 8, 4 factors. This time it should say number of factors are 4. Yes, it gave the same. So in this way we counted the factors. And now let's see the very much important another program related to this counting of factor. WAP to read a number and check whether it is prime or composite. Now let's see here. To check prime and composite, how do we do that? Actually, the number which has just 2 factors, then it is called prime. So as we learn how to count the factor, just we need to count this factor and we need to check if this f is 2. If f equals to 2, then we can say the number is prime, else print the number is composite. And if and in sub. So simply from that same program, factor counting program, after the factors have been counted out, we just need to check if f equals to 2, then it is prime, otherwise composite. And let's see here, does it work or not? Okay. So if we give here 6. Sorry, if we give here 6, it should give composite. It's giving composite, and on running this and giving 5, it should give here prime. One thing what it cannot do is, if we give here 1, it gives composite, because we had checked for factor 2. If you want to print this 1 also as prime, then you need to do like this. If f is less than or equals to 2, then print prime. The number is prime. We have one constraint here. Mathematically, as 1 has only one factor, some author does not want to say 1 as prime. So for such case, if you want to give the message that in case of 1, do not check further, in such case you can give here if input n is equals to 1, then what we can say, print neither prime nor composite, and we further can terminate the program and can write here end. So let's check this. If I give here 1, neither prime nor composite, and if run here again, if give 5, it's prime. If 2, it is also a prime, and on running this, let's check for 6, it is composite. So this program is valid for all the numbers. And now one another question, let's see. WAP to read, no, WAP to print prime numbers till 50. Yes, if we say to print prime number till 50, then we don't need to take any input over here. As we don't need to take any input, then here we don't need this. Yes, if you want to change the name of this subprogram, you can, whatever you want, but I'm not changing for this time. Okay, so as here is empty, no input is needed. When there is no input, direct call, and then here also we don't need the parenthesis factors, and even here we don't need it. Yes, and during checking, during printing the numbers from 1 to 50, so let's exclude 1 till 50. Let's generate the numbers from 2 to 50 through the variable n. Yes, so for n equals to 2 to 50. So now whatever the value of this n comes here, or whatever n creates, is that prime or not to be checked, and we need to print that. So for this n to check, or for counting the factors of n, it works. Yes, and then for that instance of n, if f equals to 2, then we need to print that n, that value of n is to be printed at that time. if its factor is found 2, that means it is prime, and we need to print that n. So we don't need these things. So on doing this, this for n is to be supplied with next n. And for one instance of n, the factor counter f will count here, and when next n will come, at that time this factor counter should restart. Otherwise the previous numbers factor are added there, and the new counting also will be continued in the previous one. That is why when you obtain new number here, that means new number is if obtained, then for counting its factor, this factor counter also should be restarted with 0. So when we do this, what happens here? For first number, the factors will be counted by this. If the number of factor is 2, then that number will be printed out, otherwise will not be printed. That means if let's at first, let's say when the value of n is 2, at the time the factor counting will be 2, because 1 can divide this for I will have 1 for the first time. 1 can divide this 2, value of n as 2, and this 1 can divide next time 2 also can divide. That means for the both instance of I, for the both iteration of this loop, the counting will be counted out, or counting will be done. That is why f will be 2. So when the loop will complete, then f equals to 2 will be true, and that will be printed out. And next time when the next will make the value of when the value of n becomes 3, what happens here is f becomes 0, counter will be reinitialized, and this time 3 has only 2 factors. It will count 2 factors, and that also will be printed out. Next time value of n will be 4. When the value of n will be 4, in that same way as we previously for the first program that we had made the Dryden table, that will work here when value of n is 4. So in case of counting this, we simply can say that it will count it out for one value of first factor. 1 will be counted out, then 2 also will be counted as factor of 4. Next 3 will not be counted out, and 4 will be counted out. That means 4 will have 4 factors, sorry, 3 factors. 4 will have 3 factors, and then that it will check here if 4 is, sorry, factor counted 3 is not equals to 2, as that is not true or false, it prints n. So very simply what we can say is, whatever the value supplied by this n from 2 to 50, for each value of that n, factors will be counted out. If the factor is found just 2, then the number will be printed out, otherwise not. So let's check. So till 50 we have these many prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, in this way up to 48, sorry, 47. 48 is not prime. 49 also can be divided by 7, and 50 can be divided by 2, 5, 10, etc. So they are not prime number, just this much is the prime number. So there is still another program related to prime number, that is we have to print this is till 50, another is first 50 prime numbers. These two are different question. In this question, previous question, we are set to print prime numbers till 50. We had printed till 47, and there were around below 15 prime numbers were there. So we need to reach up to 50 prime numbers. That means we need to go for uh, bigger some bigger values. There it should give 50 prime numbers. That is, let's say that whatever that, let's write 50,000. During this, a very simple way is when it prints here factor, sorry, when it prints here any prime number, it checks and print that prime number at that same place. Let's count is that prime. When it prints prime, let's count prime. That means if on checking the number, if that is found prime, it will print from here. On just printing this, let's count prime equals to prime plus 1. That means one number is printed out here. As soon as it prints over here, then let's check if p equals to 50. When the value of p reaches to 50, we don't need to do any further work, and we can end this loop. This loop means the next n is not to be given. So we can write exit for. This for will terminate the loop just written next to it. That means this next will not continue now. So on doing this, this is a very simple way for printing total number of prime numbers as given here. What we did here, as soon as the prime number is printed from this statement, we counted that this colon is used for breaking the statement. This is so saying that this is one statement and this is another statement. Okay, so on printing the prime number, count that prime number and check that if this counter reaches to 50, then you don't need to supply Mr. N, you don't need to supply other numbers, just that much. Okay, let's see here. Let's run and check. As we are saying here, 50 prime numbers, 50 lines cannot be printed out here, so I would prefer to use comma also here. When we print comma, the next number will just print next to it. That means leaving one tab space. So let's see here. Now it has printed like this, 5 columns, 1 2 3 4 5 6 7 8 9 10. 10 5s are 50 prime numbers are printed out. So the last prime number in or the 50th prime number is 229. That means if we had written just 500, it could work. So in this way, we can print first 50 prime number. Okay, so if you don't want to use this for loop out here, like giving 5,000 in this way, we can use another way, like 2 equals n equals to 2, starting from 2. We can use do loop, and we can use a counter here to supply new number, n equals to n plus 1, and the do can be terminated from here. Loop while p equals to 50. This n is actually increasing the value of n, and this p is counting the prime number, and the loop is continuing till p reaches to 50. Oh, this next n is not needed more now. So let's run this and check this out. Oh, sorry, I think I made, oh, I had written here directly. We should give the range here. Okay, F. Now it printed out that all. So in this way also we can write program for printing first 50. Oh, it printed out 51. I think we just need to say less than 50 because first factor gets directly printed out. So let's run and check. Okay, it printed out the first 50. So in this way we can do all the programs related to prime number. So first of all, counting, printing the factors. Next one is counting the factor. Next one, checking prime or composite. This is the most important one. And in this other two, printing prime number still 50 or prime printing first 50 prime number. In these two, we need, or we had used the nested loop inside loop as well. So class, thank you very much for today. This much for today. Bye bye.